Hello friends, in this video we are going to calculate the height of protrusions through a numerical. So let's move on to video. Let's see the numerical. A pipeline of dia 0.3 meter carries the oil at the rate of 540 liter per second. If the specific gravity of oil is 0.8 and its kinematic viscosity is 0.023 stokes, determine maximum permissible height of protrusions, that is restrictions, up to which pipes acts as a smooth pipe, and height of protrusion beyond which pipe would become a rough. Before studying this, we should know the concept of hydrodynamically rough and hydrodynamically smooth pipe. We all know that if this is the pipe having some roughness, and we know that in turbulent flow there exists laminar sublayer. So if this laminar sublayer is lying below the actual roughness or height of protrusions, then that is called as hydrodynamically rough pipe. And if this roughness of a pipe is less than the laminar sublayer thickness, then it is called as hydrodynamically smooth pipe. This is smooth pipe and this is rough pipe. So let's note the given data. Pipe dia equal to 0.3 meter. Discharge is given to us Q, that is 540 liter per second. We can convert it in our regular unit, that is meter cube per second, as 0.54 meter cube per second. For this we use relation. Here I am writing 1 meter cube is equal to 1000 liters. Specific gravity equal to 0.8 and kinematic viscosity that is equal to nu equal to 0.023 stokes. We want it in meter square per second, so it is 0.023 into 10 raised to minus 4 meter square per second. Here we use relation 1 stoke equal to 10 raised to minus 4 meter square per second. So by using this relation we can convert the corresponding kinematic viscosity. So we can find average velocity as U bar is equal to discharge upon area of pipe. Discharge is 0.54, area of pipe is pi by 4 into 0.3 square, so that is equal to 7.64 meter per second. Further we can find Reynolds number RE, that is U bar D upon nu, rho VD upon mu, or mu upon rho is also called as nu, so it becomes U bar D upon nu. So that is equal to 7.64 into 0.3, nu value is 0.023 into 10 raised to minus 4, that is equal to 996,448.34. So it is clear that RE is greater than 4000, so it is proved that it is turbulent. Logically, if we check the velocity, that is 7.64 meter per second, this value is already a large value, so we can say that from the velocity also that flow might be turbulent, but we have to verify it by considering Reynolds number equation. So if flow is turbulent, then friction factor F is equal to 0.079 upon R e raised to 0.25 that we have seen in regular formulae, list of formulae. So it becomes 0.079 upon 996,448.34 to the power 0.25. So it becomes 0.0025. Now we can find the value of tau node as F rho u bar square upon 2. So 0.0025 rho is here specific gravity. If it is 0.8, then it means this rho value is 0.8 into 1000, that is 800. So we can write rho value as 800. U bar, we have calculated u bar over here. This is u bar, average velocity. So 7.64 square divided by 2. This tau node is 58.38 Newton per meter square. So next is u star is equal to under root of tau node upon rho. So u star can be calculated as under root of 58.38 divided by 800, that is equal to 0.27. So basic formula for calculation of height of protrusion is u bar upon u star is equal to 2.5 log to the base e capital R upon k plus 8.5. Here the value of k is nothing but the height of protrusion. So 7.64 divided by 0.27 is equal to 2.5 log to the base e. R is 0.15 upon, if dia is 0.3, then half of that, that is 0.15 upon k is not known to us, equal to 8.5. So this ratio 7.64 divided by 0.27 becomes 28.3. This ratio minus 8.5, this 8.5 when comes over here minus 8.5. This 2.5 is multiplied when comes over here, it will go to on division side, that is 2.5 equal to log of 0.15 upon k. So 7.92 equal to log of to the base e 1.5 upon k. In our calculator there exists the button for log to the base e. Just put shift into log to the base e, we will have anti-log. So anti-log is nothing but the e raised to. So 0.792 equal to log to the base e 1.5 upon k. E raised to 0.792 is equal to e raised to this term, this whole term, and we know that e raised to log of becomes cancelled, so only remaining term is 1.5 upon k. So we have value of k as 5.45 into 10 raised to minus 5 meter. We are interested in calculation in millimeter, so 5.45 into 10 raised to minus 2 millimeter is the height up to which we can permit the roughness of a pipe or extrusions or protrusions. That's all. Thank you.